Alright guys, here's our triangle for question number 1 on the review. And it wants us just to find side B. But to do that, I need to know where is side B, because I don't have the labels. Just keep in mind the angle and its opposite side will always have the corresponding or the same letter, capital for angles, lowercase for side lengths. So here I now need to ask myself, what relationship do I have? So I know if I'm using law of sines or cosines. Here I have an angle. I don't know this side yet here, so that doesn't work for me. But I do know this angle, and I know this side. So this is going to be angle, angle, side. So angle, angle, side is a law of sines problem. I'm going to go ahead and write my proportion. And remember, the way I was showing you in class, on the left-hand side, fill in your two known pieces of information, right? I know that angle A is 30 degrees, and I know its opposite side. So that's my two known pieces of information. So they go together on the left. And then on the right-hand side, I'm going to use one of my known pieces of information, which is this 75 degrees. And I'm going to pair that with my unknown, or what I'm trying to solve for. So now I have sine 75, which is angle B, over little b, because I'm asked to find little b. Here I'm going to cross multiply. I'm not going to do all this part every time here on this video, but show everything this time. I have b times sine 30 is equal to 12 times sine 75. And now, since I'm attempting to solve for b, I need to keep in mind that that is in fact my variable, and that sine 30 is a number, right? I can't just divide by sine and leave the 30 behind. I can't do anything like divide by 30 and leave the sine behind. All of this has to go together. So let's go ahead and divide both sides by sine 30. On the left-hand side, these two will cancel, leaving me just the b. And over here, I have 12 sine 75 over sine 30. And that is going to solve for my side little b. Make sure we're in degrees, because our triangle is given to us in degrees. And on my calculator, I'm going to go ahead and punch in 12 sine 75 divided by sine 30. And I have 23. Let's do the approximately 23.2. And then let's just double check really quickly to make sure that this makes sense. 30 degrees made side length 12. 75 is greater than 30. So the side opposite of 75 should be greater than what is the side length opposite of 30. And 23.2 is certainly greater than. All right. Number 2, we need to find A. So first, let's identify where would A be on our triangle. Oh, here's angle A. So opposite of that is little a. I had a couple people ask me in class, is there something missing, or did you forget to draw or add some information? And what I want to show you here is, keep in mind this is a congruency marker, and I've been given this angle at 30 degrees. So I know that this is 30 degrees. If I add those together, I have 60, and that means that B is equal to 180 minus 60, so that's 120 degrees. And that now gives me a known angle right here and its opposite side. So I can start by setting up my left-hand side, which needs two known pieces of information. This is going to be sine of 120 over 21 is equal to sine of 30 over little a. And just like in the last problem, it's going to be the same steps. Cross multiply, giving me a sine 120 is equal to 21 sine 30. And recognize again that this is my variable, and I have that times this whole number. So to move this over, I'm going to divide by 120 sine. Not sure why I'm writing like that today, but it's early in the morning for a Saturday. So these will cancel, leaving me with a equals 21 sine 30 over sine 20. And if we put that in our calculator, again, we are in degrees, so be careful with that. So we got sine 120 over 21 and 30. We get 12.1. And again, always make sure, because it's so easy and quick to do, that these answers make sense. I have measure of angle B being 120 and a side length of 21. And I have A being 30 degrees with a side length of 12.1. This is a reasonable, expectable answer for this problem. All right, we've got another law of sines problem where we are being asked to find a side length. And you may ask, how did you know right off the bat it is a law of sines problem? Well, let me show you what I see. I have a known angle here. I don't know this side length, but I do know this angle. And then when I swing around this corner, I've got a side length. And I know that angle side means law of sines. So let's set it up. First, let's identify our two knowns, right? I need to know an angle and its opposite side. Well, I know this is 18 and this is 234. So I have sine of 18 is equal to 230. This triangle, if it exists, is going to be a very large triangle, right? If only 18 degrees is producing 234, and I am looking for little b, we should have quite a swing here. So if I want little b, that's going to be opposite of big B, meaning I need to know what is this angle. And we can do that by taking 180 minus 70 minus 18. And like I said, it is early, so I am using the calculator really quick to see that that's going to be 92 degrees. Just missed being a right triangle by 2 degrees. So now I know big B is 92. And I need what is little b. Let's do our cross multiplication. Let's not even do that. Yeah, we'll do it. I was going to skip some more steps, but I don't. See, still doing it on my mind. And 234 sine 92. Divide by sine 18. These guys are gone, and I can plug that into the calculator. And I need 234 times sine, horribly written 92, and divide that by sine 18. All right, we have a large number like we expected. This is approximately 756.8. Definitely greater than 234. So we're in a good position. Alright, guys, now I got number 4, and it wants us to find two pieces of information. We want both C and B. I'm going to do C first since it's up there first on the review and here, and I'm assuming there's a reason why. I don't have anything for B, it looks like, right? I don't know big B, I don't know little b, so there's going to be that little extra starting step. I am fortunate that I have angle, side, and I have my two knowns here, so this is going to be sine of 22.5 over 3/2. But why write that as 3/2 when we can rewrite it as 5 just to make our cross multiplication a little bit easier? I'm looking for C. I know the angle. I don't know the opposite side, so that's exactly the situation we want to be in. And this would be C. Cross multiply, divide, calculate, and we're done. So C times sine 22.5 equals 1.5 sine 91.3. And then we just divide all of that by sine 22.5, leaving me with C equals 1.5 sine over 91.3 divided by sine 22.5. And we can stick that in the calculator to get 1.5 sine 91.3 divided by sine 22.5. And we get an answer of approximately 3.9. And of course, we want to do the quick and easy check. 22.5 gave me 1.5. 91.3 gave me 3.9. Makes perfect sense. All right, now let's find little b. We don't know big B, but we do have two of the angles, so let's do 180 minus 22.5 minus 91.3, leaving me with a value of 66.2 for big B, and now we want little b. Now, I'm already taking a gamble here, right? I haven't verified this triangle's real, and I just used the old geometry 180 minus trick, so I'm not going to take a second gamble and use 3.9. What I want to do instead is always go back to my original, and this is why I said do it this way. If I set it up where my two knowns are always, excuse me, if I set it up where my two knowns are always on the left, I'm going to start every problem with this triangle the same way if I am looking for sides. And now I'm going to say it's equal to 66 sine of 66.2 over that little b that I am looking for. This is going to give me b sine 22.5. We're going to do that anyways. Is equal to 1.5 sine 66.2. And let's look at this once we have, well, even here. This is exactly the same setup on the left. The right's looking similar, but look what happened here. At 91.3, let's change the color. I remember there being a highlighter option. Is this it? Let's find out. So here I had sine 91.3. Now I have sine 66.2 up here. This 91.3 ended up right here. This 66.2 ended up in the exact same position. Because I started my left-hand side both times exactly the same, my 1.5 ended up in the same place. It's really going to, and then you're going to see here, we're about to divide by what was originally in the numerator, and we did that as well. So this is why I kind of like this approach, because you get the same setup, and you really could have just changed these numbers out, and you would have gotten your answer a lot more efficiently. But let's go ahead and divide it by sine 22.5, leaving me with 1.5 sine 66.2 over sine 22.5. And we can just plug that into our calculator. And that's going to be 105. 1.5 sine 66.2 divided by sine 22.5. And I am left with 3.5, not 3.6. Let's see. And just that quick visual, not visual check, but just a quick inequality, right? 22.5. Smallest angle, smallest side. The medium angle, I don't know what to call it, mid-size angle, 66.2, 3.6. 3.6 fits between 1.5 and 3.9, so that's great. Greatest angle, greatest side length. So that's a reasonable answer. All right, we're finally not finding another side length, right? We've got that find capital B, meaning we're looking for an angle. So it's going to be basically the same thing, except we have one slight modification. I'm going to go ahead and mark that as my, what am I trying to find? Let's see here. We have an angle. We have a side. We don't know this angle, but we do know this side. That is a bad word if I write it out in the order I found it. So I'm just going to go ahead and write SSA because you can read these forwards and backwards for these, well, I was going to call them congruency statements, but we only have one triangle, so these are just determination statements. And SSA always uses the law of sines. So I know big A and I know little a, so those are going on my left-hand side. It's going to be sine 32 over 68 is equal to, well, this time I want B. So here is the big change, and hopefully you guys are already ahead of me on it. If I am looking for an angle, I must use inverse sine. Inverse functions find angles. That is nowhere near the word angles. I mean, it was the intention, but it wasn't what was executed. All right. That looks like a D, but we'll call it a cursive S. So, but we're still going to, well, so we're going to do the problem exactly the same way. We're going to cross multiply. We're going to have inverse sine of B times 68 is equal to 34 sine 32. Go ahead and divide by 68 to isolate my variable B, which is part of the sine function. So I'm not going to do, just like all the other problems, I can't just divide by sine. I can't just divide by B. Sine inverse of B is the angle's measure. This is going to leave me with inverse sine of B is equal to 34 sine 32 over 68. And I can plug that in my calculator. But I want to make sure, remember, second sine equals inverse sine. So keep that in mind. Make sure you hit that second and you have that little -1 up there before you do anything. 34 sine 32. All right, so let's put this in our calculator. Now, if you're using the TI-83 for all those different models we all bring to school every day, we're going to punch it in as we see it. We're going to do second sine. It's going to open that parenthesis for us. Let's go ahead and open a second parenthesis and type in 34 sine 32. When I hit sine and plug in 32, I've got a new parenthesis open, so let's close it. Hit divided by 68 and then have two closing parentheses. And when you hit equals, you'll get 15.4. So let's just do that. And let me show what your screen should look like when you're plugging in for this. This should look like inverse sine 34 sine 32 divided by 68. And once you have that in, you hit equals and you will get 15.4. If you don't, double check that you're not in radians. Make sure you're in degrees. Let's talk about number 6 and why there's really nothing for us to do. This is where you should always read the directions on your test. Look over each question before you start doing it. And use some of the knowledge you have to make sure you're not going to waste time or see if there's anything you can gain insight from by looking at it ahead of time. And what I see here immediately is I have 120 degrees. That's opposite 17. And I know a triangle adds up to 180. So if I've already burned up 120 degrees, I have 60 left to use between this angle and this angle, right? Well, these have been called A and B so far. So angle A and angle B have to share 60 degrees split amongst themselves because C has already taken up 120. But here's where the problem lies. Even if I could make this 60 and just pretend A gets nothing, which would make this not a polygon, I have a major problem here. I don't have enough available angle for B to be greater than 120 and produce a side length that is greater than 17. So this problem right here, I don't have to do anything. I'm just going to say does not exist as drawn, right? This is not possible. I cannot have 120 degrees create a side length of 17 and then have an angle here that creates a length greater than 17 without enough angle available. So number 6, we've got does not exist. All right, number 7. Since we're just coming off from number 6 where we get to say does not exist just by looking at it and doing no math whatsoever other than understanding our theorems thoroughly, let's see if we can pull a trick off like that with number 7. First thing I'm going to do, I want to check the triangle inequality theorem. And that triangle inequality theorem tells me the two shortest sides added together must be greater than the longest side. So I have 2.8 plus 1 is 3.8. So we're safe there because 3.8 is greater than 3. Here I have a 2.3 degree angle and it's opposite 1. That's telling me I have a pretty good chance here of making this work. If for some reason 2.3 was opposite of 2.8, I know we'd be less likely to make this work because we still have 178, effectively 178 degrees to split between these two angles, and that'd be worrisome. Other than that, I'm not seeing any huge red flags, so let's determine what we're going to use, and let's go from there. This is another side-side angle because I can go from here. There's no angle known to a side to an angle. So we know side-side angle is still law of sines. And it wants us to find A and C. I put this little hat on there to say that's the capital C, right? It's growing large up to that C ceiling. So to find A, I need, well, my A is my unknown, and I have its opposite piece. So that's going to be my right-hand side. Let's go ahead and put that down. This is looking for an angle, so we're going to use inverse. And we've got this over 2.8. And then now I just need to identify my left-hand side, which is my two knowns. I'm going to have sine 2.3 over 1. That's nice. So cross multiply and go on from there. We're going to end up with inverse sine of A is equal to 2.8 sine 2.3. And because that was over 1 over there, we don't have to do any division. We've already isolated our variable. So we have 2.8 sine 2.3, leaving me with a side. Oh, I didn't do inverse. Second sine 2.8 sine 2.3 up. Uh-oh, we're in trouble here. It looks like 6.5 degrees. So let's think about what that means. I have 180 minus 6.5 minus 2.3. For this to work as a triangle, C, let's put it in red because we're not playing it safe here. We're using the geometry trick where we were assuming all of these were real. C would have to equal 171.2. Is that going to happen? I don't know. But I can tell you that there is not. I said 6.5. Yeah. That is 171 degrees to, and the difference here is only 2/10, right? If I added 2/10 to this, I would get this. All right, now I'm getting a little worried about this one because with that 6.5 degrees and that 2.3 degrees, this other angle, using the geometry method, so let's put it in red just because it's a little bit worrisome. It's going to be 180 minus 6.5 minus 2.3, leaving me with like 171.2. That means this angle for this triangle to exist needs to be 171.2. And that's a little worrisome. So let's see if we can, let's try and figure out if it works. Now, the reason I'm especially nervous is this 6.5 degree angle made 2.8. And there's only a 2/10 of a point difference between this side length and this side length. So let's see what happens when I set up for C. So I want inverse sine of big C over 3. That's going to be my right hand side, is equal to, like I had there, sine 2.3 over 1. Cross multiplying stays nice for us. We get inverse sine of C is equal to 3 sine 2.3. And what's happening here is going to be second sine 3 sine 2.3, and we get 6.9. It's not looking very good, is it? Well, it doesn't look good at all. Couple questions I want to ask myself before I move on and say this is not working out for us. First and foremost is this. In my setup, did I use any of my rounded answers? That means when I found the 6.5, did I use that? Did I use the 6? Well, obviously I didn't use 6.9 because I just found it. So double check I didn't use any of my rounded numbers. Nope. Just look over the math again. Nothing wrong with it. Call me out on the video in the comments if you see anything. But what I want to point out is, imagine you have a stick that's 1 foot, a stick that's 3 feet, and a stick that's 2.8 feet, and you lay them down, right? And we're going to lay them down in the same fashion. Here's my 1 foot stick. And I need to consider what's going to happen with this 2.8 foot stick when it meets this 3 foot stick. And it only has 2.3 degrees between them. So here's my vertex. And here is 2.3 degrees. So that's kind of what we're looking at. Even for me, that is a poorly drawn triangle. And we can see why this one is not working. This is what those cases were that we were talking about. This does not work as a polygon or a triangle. All right, so number 9. We're not going to do number 8 because we did number 8 in class, at least A and B, and then I think we left you guys as C for your homework. But number 9, we have a side angle side condition here. And anytime I have side angle side, I know I want to use the law of cosines. What we want to talk about in this one, or what there is to note, is we're looking for angle A, we're looking for angle B, and we're looking for the side little c, right? So this guy. My natural inclination is to jump right in and try and solve for A, right? It's kind of nice and set up. I don't know this angle. I know it's opposite. I have 2 side lengths and a known angle. That sounds like the perfect condition for the law of cosines. Here's the problem. If I burn up this by putting it on the outside here, and then I have inverse cosine of A here, I don't have a potential Y or Z, right? It's still an unknown. And now I've got an unknown that is not on the end, right? It's not my X. And now we're naturally in trouble. We can't solve for it. We have 2 variables. So we're going to have to take a more planned and deliberate approach for this problem. And we've got to look at what could we potentially do here. And what I'm saying is, just don't go in the order just because I asked for angle A first, angle B second, and C third. doesn't mean that's the order you have to find them in. So here, if I wanted C, I'm going to go ahead and mark this as my unknown. Then I can use 91 here. So let me go ahead and plug that in. And I'm only doing this just to see if it's even possible to use the law of cosines, even though we know it is because we said side angle side is the criterion to use law of cosines. So if I put my 91 on the outside, that leaves my C as my unknown. So that's perfect. And that keeps both of these free to be Y and Z. And now I can see I can actually set this up. Oof. And solve for it. Just keep in mind this is just multiplied there. Just don't really have that foresight to plan for it. So my unknown squared is equal to 144, 296, 256. See? Minus 2 times 12 times 16, 384. Cosine 91. 144 plus 256 is still 400. Minus 384 cosine 91. Let's go ahead and plug this in our calculators. If you have a TI-30 XA, well, you can say that one first. TI-30 XA, you're going to want to punch in 400 minus 384 times 91 cosine and then hit equals. If you're using a TI-80 anything, you're just going to type it in just like you see it. 400 minus 384 times cosine 91. And we get, and we're going to go ahead and round this, but I'm not going to round it on my screen yet. I still have one more step. So this tells me that x squared is approximately 406.7. But I need to take the square root of both sides of that. So I can do square root answer. And I can see that this is approximately 20.2. So x is equal to 20.2, keeping in mind that c is the one we were solving for. So now I have c is 20.2. Let's get the eraser out. I guess I didn't do all that crazy. 20.2. And now we can use the law of cosines to find the measure of angle A and B. So let's do that. Let's get rid of this as well. So we may not. So now if I wanted to find the measure of angle A, I have this as its opposite, so it's going to be 16 squared is equal to, and now I know this is 20.2. So my y is 20.2 squared plus the 12, right? Once I secure these two on the outside, what is left over are my y and z, and of course the order, or which one is y and which one is z, actually does not matter. So I have 16 squared is 256. 20.2 squared is 408.04. 12 squared is 144. let's do 24 times 20.2. Ooh. Okay, well, at least we're gonna. And then we have our inverse cosine of A. Let's go ahead and move this over. Since it's separated by this plus sign, I can just subtract it away. So I have 256 minus 408.04, leaving me with negative 152.04. Oh, I should have combined these first. I guess let's go ahead and subtract 144 as well. Leaving me with negative 296.04 is equal to negative 484.8 cosine inverse A. And this is going to give me 296.04 divided by negative 484.8. And then I'm going to take second cosine of that answer to get approximately 52.4 degrees. So let's talk about this little goof I made here. And just for peace of mind, see why I didn't end up with why I didn't end up with negative 152.04, but instead negative 296.4. I should have added 408.04 plus 144, giving me 552, and then from that add 256 minus 552, leaving me with negative 296.0. So what really should have happened here was this should be 256 minus 552.04. I still get 296.04. So we are good to go. So this is approximately 52.4 degrees. And we can now move on to find the measure of angle B. So B should be, well, there has to be enough information for B now, right? One thing to start thinking ahead of is we did have to round right here. We didn't have to, right? But for the sake of our sanity, we chose to round. So when we add up our angles, we may be really close to 180, but there is going to have to be some margin of error due to the rounding here of 20.2. But now I'm looking for B, and I have its opposite side. So it's going to be its opposite side squared is equal to the other two sides squared and added together. Minus 2 times the other two sides. And I picked the only side that wasn't an option. 16 times 20.2. And I want B this time, so inverse cosine of B. We still have 144 is equal to 256. 20.2 squared is 408.04. Minus 2 times 16 is 32 times 20.2 is 646.4 inverse cosine of B. And this is just getting messy. And this time I'm going to be careful and I'm going to add these together first. 256 plus 408.04 is 664.04 minus 646.4 cosine B. And let me just say one more time, the reason we can't just go ahead and do this is because I have this negative 646.4 times cosine. Excuse me. And when I have this multiplication here, I have to find out what this angle is and multiply it by 646. Or it's just the order of operations. It just can't be undone willy-nilly. So what we have to do is move this 664 over by subtracting it from both sides. So 144 minus 664.04 is now negative 520.04. And that leaves me with that's being gone. So I have negative 646.4 inverse cosine of B. And I can divide both sides by 646.4, leaving me inverse cosine of B is equal to negative 520.04 over 646.4. Sorry about that. My mind started wandering in the middle of doing the problem. Well, just kind of the reality check. 6.646.4. We got a negative number, but that's not a problem. All right. And here we get 148.65 degrees. That's not good. So, do we have a triangle? Well, no. 148 plus 91 is definitely over 180. So let's kind of think about what that might look like if we kind of follow that same rule. Pretend we have material of these lengths and we try to put them together to form a triangle. Here, I know I have 91, and then I draw it as a cube. So if this is 91, and then down here is 148, that's going to be obtuse. We have a nice collection of line segments, but we don't have a polygon. All right, here's another case for always check before you start working. This time it's not about the angles though, right? I only know one of them, so I'd have to find the other two to see, does it make sense. I do have side lengths 1 and 1, so this is an isosceles triangle, so, well, potentially. So this is also going to be 17 here. However, looking at the 3 side lengths I'm given, I know 3 side lengths is side, 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 so I'd be using the law of cosines. I'm not going to get an answer out of this one because this triangle does not exist, and I can say that through the triangle inequality theorem. And we talked about that earlier in the video, but that's just taking your 2 shortest sides, adding them together, and they must be greater than your 3rd side. There's no way that that's true, so this triangle does not exist. All right, guys, let's talk about the vector review sheet. I talked about a TA mistake earlier, and that's what we're going to talk about here. I'm going to show you what the review should have looked like before they copied it slightly, well, more than slightly incorrectly, but a lot of people in class will kind of make fun of the way in which I draw my I's, my T's, my H's. This is exactly it right here. Especially on this part, I have 2I minus 3J. That's not clear of a J, right? That looks like a comma with an ink stain above it. My I has this hook on it, so I can distinguish it between not only a 1, but now we're going to be able to say a J as well. On your review, it says 2I minus 3I, which is just negative I. This review should say 2I minus 3J, and this one is 2I plus 3J. And we're just going to do this one problem really for now on the review. And I've updated it to be what looks to be more like what's on your test. So go ahead and pause and take a screenshot or a picture of this so you can follow along. And then we'll be wrapping up the video. We're just going to do these 10 problems. And this is what you should expect on your test. All right, let's look at this new review page because, like I mentioned earlier in the video, I had a TA retranscribe it because I had it on that bright orange paper and the copier did not like it. So it's really grainy and hard to see. And he made that slight mistake of misreading my handwriting. So what I'm going to put on Canvas is your updated version of this. If you did the original, it's just a little bit more confusing. It's not as exciting really like we talked about in the video earlier. So I'm going to do the intentional one, not the mistaken one. So I have for number 1 a line that did not register. I have alpha minus W, and I can see that alpha is I plus 6J minus, and since I'm doing subtraction here for a vector that is a binomial, I'm going to need to make sure I nest it in here so I know to take care of this first, or that I'm distributing that minus sign to both of the terms. W is negative I minus 6J. And now I'm going to next, well, there's nothing here. There's no like terms, so I can't combine them. Like terms in this sense is my x-axis and my y-axis value. Can't really add those together because you're not moving, right? Left, right, up or down. So I'm going to distribute my negative in. This is going to become positive I. And this is going to become plus 6j. And I'm going to have I plus 6j. Oh, adding these two together, I get 2i plus 12j for my first answer. For number 2, we have t times CD. Where t is I minus 6j. And then c and d are scalars, but I know I can multiply scalars together, right? So I'm going to take 3 times negative 4. And now that they're nested in here, as it is drawn, I have negative 12 times I minus 6j. So if I distribute the negative 12 in, I get negative 12. And then here I have a double negative, so go ahead and change it to plus, and 6j times 12 would be 72j. See if I got room to move. For number 3, I know I'm kind of speedrunning these, but it really is just algebra 1 once you set them up and get moving into them. Here I have 4w. So that's just my scalar 4 times the values of my linear combination in w. So that's going to be 4w minus 3 alpha. And 4w is 4 times negative I minus 6j. Put a dot on there. Minus 3 times alpha, which is I plus 6j. So we're going to distribute in. This is negative 4i minus 24i minus 3i. I always want to write plus when I look, but here I have a negative 3 that I'm distributing in, minus 18j. Now what's left to do is combine my like terms. Negative 4 and negative 3 will give me negative 7i. Even I know that's a bad I. And then I have negative 24 and negative 18 for a total of negative 42j. Number 4. We're going to want to be careful with this. Generally, we can say anything, 3 minus 3 is 0, 4 minus 4 is 0, pi minus pi is 0, e minus e is 0. But here, we have alpha minus alpha. We want to make sure that we don't accidentally assume that with that distribution, everything will come through. Should it be safe? Probably. Could you prove it? Yes. Let's give it a shot, though. We have I plus 6j. That's not minus the quantity I plus 6j. Looking pretty good, right? Here's I plus 6j because there's nothing to do. Distribute this, I get minus I minus 6j. These cancel, and alpha minus alpha is in fact 0. Let's go to this color. Number 5. I have 2. The scalar 2 with w, 6 with alpha, plus et. I always want to write et, but I know e is negative 1 times t. Oh, I could have written et there and had a little fun, but whatever. So let's start doing our plugging in. 2 times w, which is negative I minus 6j. Minus 6 times alpha, which is I plus 6j. This is why I didn't want to change these up too much on you, because it's getting easier and easier to remember what they were. Negative 1 times I minus 6j. Do a distribution, combine like terms, and we are done. This is negative 2 minus 12j minus 6i minus 36j And now I'm going to distribute my negative 1 in. So this is going to give me minus I. And here I'm going to get plus 6j. So negative 2i minus 6i is negative 8i. Negative 9i. Negative 12 and negative 36 is negative 48. Plus 6 is negative 42j. So these get easier the more you do them, the more efficient you'll slowly but surely become. All right, what is next? Ooh, we have D, E, F. These are all scalars, right? D, E, and F on our paper are scalars times the vector W, which is negative I minus 6j. D, E, F are negative 4, negative 1, and 2 respectively, times, well, we gotta do those first. That doesn't really matter, I guess. Negative I minus 6j. This is just going to be positive 8 times negative I minus 6j, leaving me with negative 8i minus 48j. Let's get a new canvas. No, I could probably fit this one. Oh yeah, you can easily fit this one in. All right, next up we have 3/2 times alpha plus f times our fancy t. So we're going to do 3 times 2 for alpha, which is I plus 6j. Even my f's and t's kind of look like, huh? F is 2, and t is I minus 6j. Now here I'm just going to distribute and combine like terms. 3/2 times I is 3/2 I. Here I have 18 divided by 2, so that's plus 9j. Here I have 2 times I, which is 2i. And here I have 2 times negative 6, which is negative 12j. Now I'm sure a couple people are saying, wait a minute, wish I could raise my hand here. How did this become this? So let's take it over here really quick. We have 3/2 times 6j. Remember, this is 6j over 1. So we want to do 3 times 6, which is 18 over 2 times 1, which is equal to 9. 3/2 I plus 2i is 3.5i. Keeping in mind that this is just 1.5i plus 2i. And then I have 9j minus 12j, so minus 3j. Let's clear the canvas for FW minus FW minus FW. Context coming out. We know F is our scalar 2. So let's just go ahead and do that. And W is negative I minus 6j and negative I minus 6j. And here we have 2 times negative I, so negative 2i minus, well, 12j. Then we have times minus 2 times w, which is negative I minus 6j. So here, what we're going to end up having is negative 2 times negative I. So we're going to end up with plus 2i and negative 2 times negative 6, which is plus 12i. And what happens here, I just, well, I almost said his name. I almost TA'd myself there. Well, I actually did TA myself, right? This is a J. So now I have negative 2 times negative 6, which is 12 positive, and then a J, not an I. And once again, these cancel, and these cancel, leaving me with 0. Is it not safe to say that if I have a value minus itself, I'm always going to end up with 0? Yes. 3 minus 3, 0. Pi minus pi, 0. ln 3, no idea what that actually is. Minus ln 3. I do know what that is. That's 0. If any of these come up as a surprise, just play with your calculator for a little bit, see if you can convince yourself that anything minus itself is always going to be 0. Probably won't take too long if you choose to do that. All right, for number 9, we got 2 more to go. We have just t minus alpha minus w. This one's more than anything going to be frustrating in the fact that we just have t here, then we have to do alpha. Here's where I predict the mistakes might be made. And that's in forgetting our parentheses to make sure we distribute our negative all the way through. This is going to be I plus 6j for alpha, yep. And w is negative I minus 6j. So here we have, well, I minus 6j because there's nothing to do here. Distribute this as minus I minus 6j. Forgot what a 6 looked like, sorry. Distribute this, negative negative becomes positive I and plus 6j. Now we combine our like terms. This is 0. So I'm left with this I. Now I have negative 6j and 6j. That's also 0, leaving me with negative 6j. Now, small chance, maybe it's not going to happen. We don't know. I have I minus 6j. Oh. So t minus alpha minus w is just equal to t. It's almost like somebody planned that. All right. So if you're not sure why that worked out, what I want you to do before you watch the next problem is just tell me what is alpha, what is negative alpha minus w. And if I'm going to do that really quick, negative alpha is easy. That's going to be negative I minus 6j, which is exactly what w is. So really I just had w minus w here, so I should have ended up with t. And for our last one, this one's different. This is the one that's at the bottom of your screen. U is equal to 2i plus 3j, and v is equal to 2i minus 3j. And I'm asking you to find 2v, I don't know why, minus 3u plus 0 times u plus v minus u plus 12v. All right, before we go any further, one thing you guys are struggling a lot with on your topic 5 test is I did not say this problem may be undefined. This triangle may not exist. This equation may have no solutions. And what I'm seeing is everyone who typically does really well was held back by their not being prepared to be able to just declare something's not true or undefined or does not exist. You guys are getting into a bit more advanced mathematics. You've been seeing no solutions for a long time, does not exist is pretty new, but you are more than ready to make those types of steps. If you try a problem and it doesn't work out, and then you try it again, that's the right thing to do. Always try it at least twice. If it doesn't work out the second time, go to the next problem, do something else, and then go back to it maybe and try it a third time if it's really bothering you. But if you have 3 times in a row that this is not working out, right, go back to geometry. Inductive reasoning needs 3 pieces of evidence. You've gathered now 3 pieces of evidence, 3 different ways, or 3 slightly different ways at least, or 2 different ways, and you checked one of them again just to be safe. But you're really seeing you don't have a solution that's going to come out of it. Think about it like this. If you keep doing this problem over and over and over, and you're saying there's no solution, but you're not willing to accept it, it's kind of the same as just hitting your head against a brick wall, hoping you'll eventually get through that wall. This no solution should not be a wall. That is now that's a possible answer. That is something you should expect to see in math now. No solution does not exist if you're trying to construct something or prove something that has been constructed, a polygon, whether or not it exists. Be ready for that from here until the day you no longer use math. So it's a polite way of saying until the end, right? Just keep that in mind. Don't hit your head against a brick wall unnecessarily. And the cousin to don't hit your head against a brick wall is don't walk to an important job interview that's 10 miles away when you have a car. And what I mean by that is I have 0 times some quantity that is nested inside of parentheses. This is the equivalent of walking when you have the option to drive your car, right? This is your car. 0 times anything is just going to be 0. If you want to do all of that, oh, you can already see this is going to cancel anyways, and this is going to cancel anyways, and you're just going to be left with 12v. Then you're going to get 12v times 0. So just go with the 0. Please stop beating your head against the brick wall, and please make appropriate accommodations to make it to things on time and not worn out and tired. So here I have 2v, and v is 2i plus 3j. So this is just 2 times 2i plus 3j minus 3 times 2i minus 3j. This is 4i plus 6j minus 6i plus 9j. This is negative 2i and 15 semicolon. No, 15j. That's it. This is what you want to be practicing. This type of question. This is what's going to be on your review. I'm going to upload this paper to Canvas right after I hit stop recording and start before I edit this video. So be ready for that. And well, we'll see you on Monday or Tuesday for the test. Monday the 14th, I will have morning tutoring for pre-calculus only for those of you who want to get ready for the topic 6 test, which this is on. The next video I'm about to record for you guys is working the review for the questions that are relevant to your test. I know I said the test is going to look just like the review. I'm going to rewrite it. I've asked you to solve for too many things on one triangle at a time. Let's break it up so we can get more points on the test. So it's not going to look exactly like the review. I know it was fast. But I'm going to do the review, and we're going to simplify, streamline, and change, like we talked about, change that denominator so you don't have as big a risk per question so that you will do better naturally. So if you make one mistake on one and there's 3 questions on it, that's going to hurt.